Welcome to clickmyprojects.com. Here we discuss about cost-sensitive semi-supervised discriminant analysis for face recognition. Facial recognition system is a computer application for automatically identification or verifying a person from a digital image or a video frame from a video sources. One of the ways to do this is by comparing selected facial features from the image and facial databases. Some facial recognition algorithms identify facial features by extracting landmarks or features from an image of the subject's face. For example, an algorithm may analyze the relative position, size, and/or shape of the eyes, nose, cheekbones, and jaws. These features are then used to search for other images which match features. Other algorithms normalize a gallery of face images and then compress the face data, only saving the data in the image that is useful for face detection. A probe image is then compared with the face data. One of the earliest successful systems is based on template matching techniques applied to a set of salient features, providing a sort of compressed face representation. Recognition algorithms can be divided into two main approaches: geometric, which looks at distinguished features, or photometric, which is a statistical approach that distills an image into values and compresses the values with templates to eliminate variation. In face recognition applications, one is often confronted with high-dimension data, and it is necessary to transform these high-dimensional face data into a low-dimensional face space, because high-dimensional data usually deteriorate the performances of classifiers and lead to high computational complexity. Over the past 2 decades, a large number of dimensionality reduces algorithms have been proposed and successfully applied to the face recognition. Cost-sensitive learning is one important topic in the data mining and machine learning community. In such settings, cost information is introduced to measure the importance of different samples in different classes and different costs which reflects different amounts of losses. The aim of cost-sensitive learning is to minimize the total cost rather than the total error. Generally, there are two kinds of misclassification cost. The first is class dependent, where the cost of misclassifying any example is class A to class B are the same. The second is example dependent, where the cost of the classification example in class A to class B are different. In this paper, we focus on the former one because face recognition is generally a class-dependent cost-sensitive problem. So in this paper, we propose a cost-sensitive semi-supervised discriminant analysis is to learn a discriminant feature space by making use of both labeled and unlabeled samples in a cost-sensitive settings. Specifically, we first reconstruct an unlabeled sample from the labeled data and use the reconstruction coefficients to end a soft label for each unlabeled sample. Then we learn a low-dimensional features subspace by utilizing both labeled and unlabeled data, such that the low overall loss is achieved when recognition is performed in the feature space derived. Experimental results on cost-sensitive face recognition are present to demonstrate the efficiency of proposed method. This is the flow diagram of our project. In the first step, we initialize the images. In this block, it checks the size of the input images and reshape the images to the required size. Here we provide the pre-processing process like noise removal, image enhancement, etc. Then this enhanced image is given to feature extraction stage. Here we extract the feature values like shape, color, contrast, etc. Then from this feature extracted, we separate the labeled and unlabeled images which are present in the database. Then we find the weight calculation for the given images. Then we arrange the labeled matrix generation for the given image. Then finally we estimate the cost values for that image. From this cost value, it detects whether the input image is matching to any other images which are present in the database. Finally, we extract the matched image which are stored in the database. Thus we recognize the image or face of a person. Now I am going to explain the running process of our project. Now just run main.yum file. Here we create a guy creation for our project. In the first step, we capture the face image of a person. Here we insert the face image by clicking Insert button. Now we select a face image. The image in this axis displays the face image which we have to given. After that, we calculate the weight values and extract the feature values by clicking Weight button. Here, the matrix in this displays the weight values for the given image. Then we finding CS3DA. Here we separate the labeled matrix and cost and eigen values by clicking CS3DA button. Then we apply the label prediction which are displayed in this matrix. We separate the labeled images and finally we perform the labels for each and every images, and these are represented in a matrix. Then we find the cost values for the given image. After that, we finding the eigen values for each and every pixels in the given image. Since in this method we arrange the image pixel values into matrix and we calculate the eigen values for that matrix. Then finally we perform the CSDA, that is cost-sensitive semi-supervised discriminant analysis. Then finally we recognize the face by clicking Recognize button. Here the image displays in that shows the matching face which are present in the database. The first image displays the input given image. The second image displays the recognized image which are matched to database. Thus we recognize the facial images by using cost-sensitive discriminant analysis. Thank you.